For this lesson is that students will be able to analyze in writing exponential scenarios using percents, fractions, and decimals, as well as the following language: if-then statements, exponential growth, and exponential decay. So what do you think you're going to learn how to do in this lesson? All right, so anytime you're dealing with um, percents and fractions and decimals are all the same thing. They're just written in different forms, and we use them for different reasons. So anytime you're taking a percent of something, the word of in math means multiply, and so you're multiplying it. If you keep taking the same percent of it over and over again, you're multiplying it repeatedly, which makes it exponential, which is why percents often turn into exponential functions. So just like in the last lesson when we had to deal with percents of for interest for loans and for savings accounts and credit and the stock market and stuff like that, those work in exponential ways often. And there are other real world situations where we use percents and fractions and decimals as well that end up being exponential. So let's talk about it. First, a new vocabulary word is whenever you see the word exponential growth, it means it's growing, which means it's going up. So the graph is going up, meaning that it's positive. And this happens because b is bigger than 1, the thing you're multiplying. Remember, b is your multiplier, meaning you are multiplying by more than 1. Versus exponential decay. Decay means you're getting rid of it, which means you're going down, which makes it negative if it's going down from left to right. And this happens when b is less than 1, because you're timing by a percent that's less than 100. So this happens when you are multiplying by less than 1. So in real world situations, they're going to use words that mean multiply by something. For example, if they say to double it, it means to multiply by 2. Again, whatever you're multiplying by is your b. So b would be equaling 2 in this case. Versus the word triple is what they mean to say when it's multiplying by 3. Quadruple it. So the word quadruple, if they were to say quadruple it, it means multiply it by 4. And if they want to say times 5 or times 6 or times 7, they'll say that. There's no special word to mean anything bigger than 4. Twice is another way to say double. So it also means to multiply by 2, if they say twice as many. For things smaller than 1, like fractions, they might say take half of it, which is like 50%, or it's the same thing as dividing by 2. So 1/2 is like multiplying by, and you can either do the fraction 1/2, you could also write it as 0.5 for the decimal. So b is going to equal 0.5 or 1/2, depending on how you want to write it. 1/3, a third, it's like 3, so it means multiply by 1 divided by 3. If we did 1 divided by 3 in the calculator, we're going to get a decimal that's 0.3333, so it's better to write it like 1 divided by 3 to use the fraction than it is to use the decimal. One-fourth means divided by 4. So 1/4 means 1 out of 4. If I were to divide this, I do get an easy decimal like 0.25. So you could use the decimal 0.25 if you wanted to. And for all other fractions, it doesn't have to say 1 in front. It could say like 2/3. And that means the top is 2 and the bottom is the 3. Because the first number is the top of the fraction. The second number will end in a TH sound to say it's the bottom of the fraction. So for example, if I wanted to say this aloud, they'd say 3 for the top and then fifths for the bottom. So the TH tells you it's the bottom of the fraction for that second number. So that's how you'd say that fraction. It's 3/5. The only other thing is they don't have to put 1 in front. They could say like a fourth. And a fourth still means 1 out of 4 because a is only having a single 1. All right, so that's everything about the words that they could use to explain this. Let's talk about percents in general. Let's try to work on understanding percents. So first of all, whenever you multiply something by 1, you're keeping the entire amount of it. Like, for example, 5 times 1 keeps all 5. You're keeping 100% of what you started with when you multiply by 1. Because multiplying by 1 is the same thing as keeping 100% of it. So you can figure out the percent of something by multiplying, because the word of in math means multiply. So you can multiply by the percent, but there's a rule. You have to turn the percent into a decimal or fraction first. You cannot do it in percent form. So for example, the decimal for 100 is 1, because what you do is you divide the percent by 100 to figure out the decimal. So if I took 100 and divided it by 100, I'd find out that decimal is 1. So for example, if I want to do 50% of 80, first of all, you take 50% and you divide it by 100 to get the decimal, which is 0.5. The word of in math means multiply, and I can represent a multiply with the parentheses, and it's of 80. So if I want to take 50% of 80, I take 0.5 and I times it to 80, and I'd figure out that 50% of 80 is 40. And that's how you figure out percents of a number. You turn the percent into a decimal, and then you multiply. 50%, the fraction for 50% is 1/2, because having 1 out of 2 is having half. But note that 1 divided by 2 is 0.5. So 50% is the same thing as 0.5, which is the same thing as 1/2. They all mean the same thing. So if you wanted to type in 1/2 of 80, you could. You'll still get 40. It's the same math, just done in different ways. So if I want to do 25% of 80, I take 25, I divide it by 100, and figure out that 25% as a decimal is 0.25. And then of means multiply, 80. So then I'm going to multiply that to 80 to figure out that 25% of 80 is 20. If I wanted to do 100% of 80, well, 100% divided by 100 is just 1 for 100% times 80. And 1 times 80 is just going to be 80, the whole 100% of it. If I wanted to do 5% of 80, well, 5 divided by 100 is 0.05. So at this point, it's important to note that some people see this one and think 0.5 means 5%, and that's not true, because that's 50%. So 5%, when you divide it by 100, it's 0.05 to say 5% of 80. is going to be 4. Because 5% is a very low amount. All right, so with exponential functions, you're going to have 3 possible situations. You might be taking the percent or fraction of a starting amount. And that's what we did here. We were just taking our starting amount and saying what is 50% of it, what is 25% of it, so on and so forth. However, you could also be losing a percent or fraction of the amount or gaining a percent or fraction of the amount. So let's do examples for all of them so that you understand. Example 1, a baby chicken starts at 2 ounces. For the first year of its life, it grows exponentially where each month it gains 8% of its current body weight. Our equation is that the weight of the chicken is going to equal the starting amount, which is what? Starts at 2 times, and we have to figure out the multiplier. Well, the percent that's in here right now is 8%. So if I take 8% and I turn it into a decimal, it's 0.08. The power of x for how many months go by. Here's the thing about this formula. If I put a 1 right here and just did 2 times this 0.8 just one time, so I'm going to times this by 2, the answer is 0.16. Here's the thing, it's not like the baby chicken is going to start at 2 ounces and then drop down to a decimal of an ounce. Like, this isn't the new weight for the next month. That went down, and it's saying that each month it's gaining 8%. So this is what gets added on to the first 2 ounces. So that means my multiplier isn't 8%. It's the whole 2 ounces, the whole 100% we had, plus the 8% that it's gaining. So it's actually 108% that's the multiplier. So when you divide that by 100, it's 1.08. So now when I do 1.08 times the 2, I get the 2 ounces it originally had plus the 0.16 more that it's gaining. So going back to the equation though, the equation has an x up here. So here's the thing, if you're gaining a percent, you have to add that percent to 100% first. So when you are gaining a percent or a fraction, you have to add it on to the whole 100% of what we started with to figure out what your multiplier is going to be. Because it's the whole 100% plus the 8%, which gives us the decimal 1.08 for the final equation. So then the next part asks, how much is it going to weigh after 1 year? So I'm going to take my equation, and then what am I going to plug into x? Note how I said beneath it, pay attention to the time in the situation versus the time in the question and convert accordingly. This is asking about a year. However, we do not put a 1 here because in the original question, it says for the first year of its life, it grows exponentially where each month it gains 8%. So this x in here is about months. So if they're asking how much it's going to weigh after a year, well, that's 12 months later. So you have to put a 12 in here. So you're going to take 2 and times it by 108% as a decimal 12 times. Do that, 2 times 1.08. We're going to times that 12 times. It's going to be 5.03. And the other thing about word problems like this is the test expects that you answer in a full sentence, relating your answer back to the situation. So the question is, how much will it weigh after a year? And a good response is the baby chicken will weigh 5.03 ounces after a year has passed. All right, so this is a gaining percent example. Example 2 says the pool has 30 gallons of water in it. The sun is evaporating it at a rate of 2% per an hour. And assume that the sun is only out 10 hours a day. So our equation is that y equals, and what's the starting amount? 30. And what's the multiplier? Well, the percent right now is 2%. And if I divided that by 100, that's 0.02 to the power of x. And if I were to take 30 and times it by 0.02 just one time, the answer is 0.6. So if I did it only once, the answer is 0.6. Which, if I thought that it was just 2% as my multiplier, that means in 1 hour, because the time says per an hour, it goes from 30 gallons to less than 1 gallon, to just 0.6 gallons. That is not what happens, because it's only losing 2% of it. Evaporating means it's disappearing, and it's only losing 2% each hour, which means this 0.6 is how much it's losing each time, which means I have to take my 30 from the original and then minus the 2% away to say that I'm left with 29.4. So for the equation to represent this, though, 0.2 isn't my multiplier then, because I had to do the whole 30 and minus my 0.6 to figure out the answer to how much I have left after an hour. So my multiplier is actually the whole 100% minus the 2% that's evaporating, to say that I'm going to be left with 98% each hour. So if I divide that by 100, I'd find out that my multiplier is 0.98. And now if I times that by 30, I'd see that after an hour I'm at 29.4 because the 0.6, the 2% got disappeared. It subtracted because you subtracted the percents here. So when you add to the power of x, that's the equation for this situation here. So how we figured that out is that when losing percents, you subtract the fraction or percent away from the whole 100% we started with. So in this case, we had 100 and we minus the 2% to figure out that we were left with 98%, and that was our multiplier. To figure out the multiplier. And then the question they're asking is how much water is going to be left after 30 days. So then you take the equation, and what are we going to plug into x? Okay, well, it's 30 days in the question, but in the situation up here, it says per an hour. So x is representing hours. And they're saying the sun's out 10 hours a day. So each day there's 10 hours. I'm timesing it by 30 days going by to figure out that my x has to be 300. And then I'd realize that after 30 days, there's only 0.069 left. So to write my answer in words, after 30 days, there will be 0.069 gallons of water left in the pool. All right, so this one says a car is only worth 80% of its value from the year before. I bought a car that was worth $20,000. So what equation is going to represent how much the car's worth? Well, we start with y equals, and then what's RA? $20,000 is how much I bought the car at, and what's my multiplier? Well, the percent says 80%. If I divide that by 100, I get 0.8. And this time, it is the multiplier. Because I'm not gaining 80%, I'm not losing 80%. It's that each year it's worth 80% of its value from the year before. So because of that, the decimal is just the way it is, because you're neither gaining nor losing. You just leave it as it is. If you're neither gaining it nor losing it, it's just the percent of it that's left. So the word problem asks, how much will the car be worth in a month? So what do I plug into X? This one's tricky because the time from the situation says a year. This wants to know how much in a month. Well, a year has 12 months in it, and you only care about one of them. So the X is a fraction. It's 1 out of 12. Because if the X up here represents a year, and you're only looking at a month, that's a 12th of the time. 1 out of the 12 months is going by in the year. If I type it into Desmos, I'd find out that my car is, after a month, is worth $19,631.53. How would you rate it in a full sentence as a response? I would say after 1 month, the car is worth $19,631.53. All right, 3 more, this time with fractions. This one says a tree starts at 5 centimeters. It is expected to get 1/4 taller every week. Which one is the right equation for the situation? This one would have been the right one. And let's talk about why. It's getting 1/4 taller, which it means it's a gaining one. Because it's gaining, it means you have to take the whole 100% and add the 1/4 on. Well, 100% as a fraction, in terms of fourths, because this one's in fourths, I'm going to make 100% in fourths too. And 100% as a fourth, it's 4 out of 4. Because having 4 out of 4 is having all of them. So it's all 100%. And I need to add on 1 more fourth. And so altogether, from these 4 here plus this one here, when you add fractions, you only add the tops. So that's 5/4, because the bottom stays the same. And now this is the equation. How tall do you think it's going to be after half a year? All right, well, 26 is the X, because this is in weeks, and this wants to know about half a year. And since there are 52 weeks in a year, and I'm taking half of that, it's 26 weeks that have gone by. So I can go over to Desmos and type this in with the 26 and figure out that this is my answer. And so the tree will be 1,654.36 centimeters tall after half a year. All right, next example. A pond has 500 fish in it. The pond gets infected, though, and 4/5 of the fish die each day. Which equation represents this? This is the right equation. Y equals 500 times 1/5 to the power of x. If the pond's infected and 4/5 of them are dying, you don't put 4/5 here, because that's not how many you have left, that's how many you're losing. So you have to take the whole 100% and minus away 4/5 of them. Well, 100% as a fraction that's out of 5s is all 5 out of 5. And I have to minus the 4/5 that are dying away. And then 5 minus 4 is just 1/5 left. And so that's what goes in here for your B. And then how many fish are going to be left after 3 weeks then? Well, first of all, the x value is going to be 21 because it's 3 weeks that they're asking about, but the situation came in days. And so there are 7 days in a week, and 7 times 3 is going to be 21. And then when I type that into Desmos, I get 1.04 with this 10 to the power of negative 12 after it. And whenever you see this, it means the decimal needs to go backwards 12 times. So it goes backwards once to say 0.104, but also it needs to go backwards 11 more times. So there needs to be 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so that's the answer. Here's the thing. It's really, if you just take the first couple of decimals, that's 0.0, 0.00. There are no more fish. You cannot have a decimal of a fish like this. So the answer is after 3 weeks, the pond will have no fish in it. And finally, a man spent the day counting clouds. In the morning, the sky started with 4,500 clouds. Each hour, 5/7 of the clouds were left. So what's the equation to represent this? All right, so this is the equation. Y equals 4,500 times 5/7 to the power of x. It doesn't change, the fraction doesn't change because you're not gaining clouds, you're not losing clouds. There's exactly 5/7 left. So you just put 5/7 in there. All right, how many clouds are left 9 hours later? So you put a 9 right here because the question's asking about hours. And the situation up here says each hour 5/7 of the clouds are left. So the time is the same in both, so you can just put the 9 in there. And when you do, this is the answer you get. So after 9 hours, there is, and then it's really hard to have a decimal of a cloud. It's a cloud. So because you can't have a decimal of a cloud, it makes sense to round down and just say that there's 217 clouds in the sky. All right, and that's how you work with percents and fractions with exponential equations. So using if-then statements and the vocabulary, explained what you learned how to do in this lesson.